Kia ora, everybody. A tough question has turned up in the physics assignments, and it's let's get my pointer to work here. It's question 4 on page 131 of our workbook, and the workbook looks a bit like that. It's the one written by Dave Housden. So here's a picture here. The aroha is standing on a beam. The beam is 4 meters long. There are two supports. They're in half a meter from each end, and aroha is standing 1 meter in from one end of those supports. And the upwards force on the end here is there's 420 newtons of force upwards of support. And the first thing says, what does equilibrium mean? Well, it means that there are no net forces and no net torques. The bench has a constant velocity of 0. If it's constant velocity, and it is because it's not moving, then the total forces are 0 and the total torques are 0. Forces up and forces down. Clockwise torques match the anti-clockwise torques, and I have forgotten a little bracket there. Oops, oh well. Now, if we look at the forces up at B being 420, that's up there as I said. A couple of things we need to know. We need to know that aroha is standing 2 meters in from one end, because we need to find the mass of the bench, the mass of this thing here. What is the mass of that? It's quite a cool question, actually. Using symmetry, the support force at B will carry half of the weight of the plank. If it was a different number here and here, then it wouldn't be symmetrical. Plus, the bench is also carrying half its share of aroha weight. So, half of the weight of the bench plus a chunk of aroha's weight adds up to 420 newtons. That's kind of cool. I'm now going to consider aroha alone and separate the question. So for a little wee short time, I pretend that the bench is weightless. It's not. We'll add it back in again in a minute. And I want to take torques about end A. That's this end up here. This is A here, taking torques or moments or about that end there. The clockwise torque here will be caused by the weight of aroha, trying to rotate it this way, and the weight of the beam, trying to turn it that way. I'm going to leave the weight of the beam off for a minute. The weight of aroha is going to be 55 kgs times 9.8 newtons per kilogram, times her distance, which is 2 meters, and that gives us 1078 newton meters clockwise, and behind my picture here, I've got a little arrow going clockwise. Hold that thought. Anti-clockwise, the only forces trying to make this whole system go anti-clockwise, in other words, turn that way about this pivot, is the force up at B times 3 meters. Well, for equilibrium, I'll go back a step. That's not 420 at the moment. The 420 includes what we're looking for here, plus the half the weight of the beam. So for aroha alone, the clockwise torques equal the anti-clockwise torques. So the anti-clockwise torque is 3 times FB. That's going to be equal to 1078. Divide both sides by 3. We get 359 newtons of upwards force here to stop aroha falling down. Now, the total force there is going to be 420. So the bench applies the difference, which is 420 minus 359, which is about 60.67 newtons. And this is half of the bench's weight, so the bench weighs twice that, which is 121.33333 or so. We divide both sides by 9.8, because that's in newtons, gives us a bench mass of 12.4 kgs. And the book says 12. I think 12.4 is probably a better answer. I hope that helps.